Hello, welcome to FX PhD. My name is Matt Leonard and this is class number 8 of arn201 Real World Lighting and Rendering in Arnold. Okay, so in this class we're going to start off by looking at particles and how they work with Arnold. So first off, there are some current limitations, and this is as of version 1, which is obviously the version we've been on all the way through the course. So the first one is that blobbies, clouds and tubes are not supported. So if you want to render those, we're going to have to go back and use something like mental ray to do that. Okay. There's also some limitations with the UV coordinates in particles and some textures not working properly. So things like the Maya ramp texture, for example, doesn't always work the way you might want it to. Also, the particle cloud shader is not supported. There's limitations on the IPR functionality with particles, and instancing is not supported yet with hierarchies or groups. And then finally, particles that are deformed using things like lattices are also not supported. Okay, now that may sound like a long list. It is reasonably long, but many of these things you may potentially not really need to do with particles, so hopefully it's not going to limit us too much. Now, having started with what it can't do, let's have a look at what it can do. And what it can do is actually quite a lot. So let's start off by loading our scene. So we're just going to come across to open scene. And in our folder for this week, we've got pill 01. And what we've basically made is just a straightforward kind of medical pill. One of those adverts that you might often see on TV where the pill kind of splits open and out comes a load of kind of particles or whatever's inside the pill. Now, I've already rendered out a version of this so you can see what it looks like, or rather a play blast. So let's just have a look at that. It's going to load up fcheck. And let's just go ahead and load those files. So they appear in your images folder once you've run them. You can see they're here. If I just move this over, you can see that's the animation we're getting. Okay, so it's just running over about 200 frames. Okay, so let's close up fcheck. And let me just explain very briefly how I've gone about making this. So I'm just going to quickly make a new scene. Let's make just a straightforward sphere. I'm just going to go into the faces and I'm going to cut the top off somewhere around there. Go back to object mode, and then going to take this and we're going to come up to N particles, and we're going to say that we're going to make some balls, and we're going to say that we're going to fill an object. Now this works really well. The thing you need to be aware of is the resolution. So with a resolution on its default setting of 10, you can see when we fill the sphere, we get that number of particles appearing. Okay. If we make it larger, let's say 40, and we fill it again, you can see it's going to take a lot longer to do it. Still thinking about it. And what it's made is many, many more particles. So we have a huge number of particles compared to what we had originally. Okay, so just be aware of how many you need to fill up your area. I'm going to go with 20, and I'm going to fill it with that number. Okay, let's close that down. Now, initially, if I was just to hit play, you can see they're just going to drop through and drop straight through the floor as well, which isn't very helpful. First thing we want to do is go up to our nucleus solver, and we want to say that we want to use the ground plane. This is like putting a plane in and you're then setting gravity so that this lands, all the particles land on the floor and interact with it. But you can see here it's working really nicely, especially if we put it into solid mode and give ourselves a few more frames just so we can see what it looks like. Okay, but obviously the problem we've got is that it's tipping out of our container, and we don't want that. They're just dropping through. So we're going to come in here, we're going to select the container, and we just say this is a passive collider. Passive meaning that it won't be affected by gravity or wind or fields, that kind of thing. So if I now hit play, you can see what actually happens is they actually drop down and they come to a rest position where they're kind of quite happy. Now some have fallen through. That sometimes happens. But most of them have kind of happily rested. Now the ones that are falling through, this is all to do with kind of iterations of the dynamics and all those kind of things. I'm just going to ignore that for the time being. Forget these are falling through. I'm just going to select my particles and I'm just going to come up to nsolve, initial state and set from current. What this means is that now when I rewind, all the particles remain in the same place. So when I play it, they don't kind of go back to that kind of position where they're at the top. They're actually all quite happy, rested in there and settled. So what I can now do is I could just come into my timeline, come up to frame, say 10, and grab my container, and we can literally just now animate it tipping over. So I'm just going to set a key on rotate there. I'm going to come up 20 frames and let's tip the whole thing up quite radically, right upside down there. And you can see that they're not really going to fall too far. So what I'm going to do is I'm going to come over to my nucleus solver. I'm going to come to where my ground plane is, and instead of it being the origin at 0, 0, 0, I'm actually in Y going to drop it down by 2 units. So you can see this green plane is really now where the floor is going to be. It's not going to be where the grid is, so let's hide that. It's going to be where the floor is based on this green square here. So let's give these a little bit of bounce. Friction and stiffness, or stickiness rather. Let's now rewind. Let's just move over here and just hit play. And you'll be able to see this now running through. This is exactly what I did for the pills, but I obviously used 2 pieces. So there they are, they tip up and out they all cascade. Okay, wonderful. Really nice system, works very quickly once you know how to do it, obviously. And there they all come. So that's really how I set this up. Now if we come back to my scene, you'll notice that on the top we have this controller. This is very simple. It was basically something that I set up right at the beginning that enabled me to control the opening and closing of the pill based on this one control here. So if we look at the animation editor, or the graph editor rather, you can see that what we've got is just a straight curve that goes from 0 degrees up to 45 degrees. Okay, from frame 50 up to 75. Now that control is actually controlling our 2 rotation locators here and here. Okay, and they have expressions on them that are basically relating back to our controller. Okay, so as this rotation on the left rotates up based on our pill opening control, it drags both the outer casing and this inner casing, and it's the inner casing that has the passive collider set. Okay, so there's 2 kind of levels, one that's really just to look nice, and then one inside that's grey is there just to control the particles and hold those. Now it's worth noting, if you come across to here and look at their render stats, they've actually got everything switched off, so you don't see these if you render them. So if I do a quick render here, you'll see that we're not going to see the casing, but we will see the particles. Okay, so they're the particles, but not the casing. Okay, so if we come back to our rotation, our channel box, this is where our expression is. The kind of the pinky color tells us that there's being controlled by an expression. And we just come up to edit expression. You can see what we've got is that the rotation Z is being controlled by the pill open, which is this locator, and then its attribute pill open, which is just this attribute here. Okay, so that's how it's working. Now, in order for one to open one way and one to open the other, one I've just got a minus sign in front of, and the other side it hasn't got a minus sign. So that's why they both open kind of in opposite directions when you use that control. Okay, so that's what I've done. And now let's just have a look at how we can actually use these particles with Arnold. So we'll run this through just for a few frames until the particles start spilling out, and then we'll look at how we can render those. So open it comes. Here are all our particles. Now let's stop the animation around there. Select our particles. We'll just go to a wireframe view for the moment. So you can see they're selected. Let's come across to our attribute editor, and you can see here we've got our shading. And at this point, our shading is set to points. Okay. Now with this set to points, what we actually get is then something happening under our Arnold tab. And that is the render of the points are being controlled by this attribute here. We can either set them to render as points, spheres, or quads. Also, we can define the overall radius and then the radius multiplier, which usually is set to 1. Okay, so I'm going to leave this set to say 0.025, and let's render this so you can actually fully see these particles. And in order to get this to look reasonably nice the first time, I'm just going to leave these settings of AAs at 3 and then everything else down at 1, 1, 1. Subsurface scattering can be at 0 because I don't have any subsurface scattering, and in fact you don't have any refraction either, so that can go down to 0. So let's render this through just so you can see what we're getting at this stage. Okay, so that's now finished. You can see that with it set to points, we're getting this really nice, almost like disc effect with our points here. So let's just again grab our particles. Let's come across to our render points as and just change it to spheres this time. So I'll save this and re-render again. Okay, and you can see that took pretty much the same time. And we're getting these really nice spheres now, really nicely lit and sat there. Let's now come across and change them to quads this time. And this is actually going to make cubes. So again, let's just save this so we can look back. So that was points, that was spheres, and this one is going to be our quads. Okay, so that one's finished, and that one took just a little bit longer, but we now have these nice cubes. So you can see again the points, spheres, and cubes or quads. Okay, so really nice. You can see between the quads and the points, they're giving us a very similar look, but the spheres have got this really nice kind of highlight on them. So they actually come across looking quite different. Okay, just that we're not really getting any of that specular highlight on either the points or the quads. Okay. So next up we have minimum pixel width, and this only works when your render points are set not to quads or spheres but to points themselves. Okay, now if it's set to anything above 0, it basically will automatically enlarge the pixels, or enlarge the particles rather, so that they are at least the specific size in pixels that you set here. Okay, so if we set these to say 1, and we set this radius multiplier down to say 0.01. So we're going to set this very small. And let's just bring up our render just so you can see what we have. Let's grab a section and do a quick render. What we're going to see is this is going to actually push the pixels up to this minimum pixel width of 1 unit. So you can see now we've rendered that. What we're getting is our minimum pixel width of 1 pixel. If we then come in and say change it to 5, and let's just render, say, this section here. In fact, this section in the middle, that can be at our 5. That's going to set the minimum pixel width to 5 pixels for our particles. You can see what we get there. And we can also, if we wanted to, make it even larger to say a value of, say, 10. So again, I'm just going to come in and grab this section and render. Now, the reason why we might want to do this is because it basically makes it a lot easier to anti-aliasing very small pixels. Okay, so basically you can use this to add minimum width and then really just helping yourself get the right amount of anti-aliasing on those, because obviously when you've got very small particles it can be very difficult to get the right amount of anti-aliasing. So you can say I want to set a minimum pixel width based on whatever it is that we've got here, for our particles so that we know that Arnold is controlling the anti-aliasing in a sensible way. Okay, so really we want to set this value not to 5 or 10, but somewhere between 0.2 and 7 is what Solid Angle would recommend. So again, if I just grab all of this and we render it at that specified amount, 0.2, 0.7, something like that. Even when they're this small, we're now getting really nice anti-aliasing across those. And you can see they're still looking really nice, even at that very small size. Okay, so you can see them there, just finishing off. Okay, so that is the minimum pixel width. I'm going to set that back to 0. I'm going to set my multiplier back to 1. And let's move on down now to this delete dead particles. Now what this option basically does is it disables the rendering of particles that exceed the maximum particle lifespan when using motion blur. Okay, so if you find that a particle is existing longer than you wanted because of the motion blur step size and how that's working, you can use this to basically kill the particles. I tend to have this on all the time. Whenever I get down this section, I just click it on just to make sure that we haven't got particles that are kind of motion blurring past your collision plane or something like that. Okay, so I always try and keep that set to on. Now from here, let's go and have a look at the pixel sampler info. Okay, so let's say now we want to add something that's going to make our particles change color based on age. Now there's a little problem that you'll come across that's easily fixed, but let me just show you how you do it. So I'm just going to save my scene as PIL02, just so you know what that one is. And let's just go ahead and make a new scene. Let's quickly make a new particle emitter. So we're going to make balls again. We're going to create an emitter this time right in the middle of our scene. And we're just going to move it up a little bit and hit play. And you can see they just come out like this. What we want to do is just make a kind of a fountain effect. So let's make about 250 frames. Let's come to our emitter and we want to come to our speed and we want to push those up slightly. So they're going to emit upwards. We're going to come to our emit type or emitter type, make it directional. And we're going to say that the direction is going to be up. So we want that to be 1 in the Y. Spread, let's put it to say 0.5 for the moment, see what that gives us. Or 2.5, let's say, and just hit play. And hopefully we should get something going on. Nice there. So it's still not really going up high enough. So let's set our speed to say 15, our spread down to something even lower. And again, play. Now that's looking much better, much nicer kind of little fountain we've got going on there. Let's make sure our nucleus is set to use the plane. And we can see now they come down and they just should hopefully land on the ground once we rewind everything and play again. Without doing that, you won't get the update taking place. Okay, so there's our fountain. So first off, let's just take our particles and let's change those. Let's see what we've got them at the moment. Set to blobbies. Let's just make them say spheres. So if we zoom in here, we're also going to just set a skydome light and just do a quick render so we see what we're getting. Okay, not a huge amount. Let's see if they're there. Nothing, because they are the Maya renderer. Forgot we reset. So again, IPR. There they are. Nice white shapes. So call up our render hyper shader. And the way that you could often do this would be, let's go ahead and make, say, an Arnold shader. Arnold standard. I'm going to change this, in fact, to a surface shader. We're going to add a ramp in the background. So let's just see what we get here. There's our ramp. We don't need our place 2D texture. What we do need is a sample pixel sampler here. Okay, so our ramp we're going to say is U. It's looking right. Drag this over, pixel sampler info into the ramp. Other. We're going to set the age of the particles to be fed into the U, and the out UV component, UV coordinate, the V, goes to the V. Okay, so before we use that, let's just make sure that our particles are actually set to a useful time to live. So let's say 100, and we'll give it maybe 5 random. Okay, so if we play that, maybe we set that too high. Let's bring that down a bit. So my initial guess was way too out. I thought it was frames for a moment, but it's actually seconds, if we remember rightly. Okay, so they're definitely beginning to die off now. So if we take all of this, take our particles and apply this. And let's just move this out of the way for a moment and render. So what we should be getting is lots of different colored particles. But you can see what we're actually getting is just red. And that is the problem that we have. What we need to do to fix it is come down to the Arnold section here, and under the export attributes, we need to type the same thing that we're trying to achieve. So we're trying to get the age. So you type age in there as the export attribute. Now when we re-render, you can see it's working perfectly. Okay, so I just wanted to show you that little gotcha, because it's something that you obviously often need to do, and without putting this in, you can end up with some problems. Okay, so that is just how you set the particle to change color over time, okay, based on our colored ramp that we made. So I'm just going to take this small example and just save this as a particle age 01. Okay, from here, let's have a very quick look at motion blur. So maybe we'll keep with this example while we've got it up. Now, when it comes to motion blur, the main thing to be aware of is that the particles need to be cached in order to get the motion blur to evaluate correctly. Okay, so if we keep with the frame we're on, let's just go across to our render settings, go across to motion blur, and we'll just enable it. I'm going to set a few more keys, maybe just 3 keys, and let's just increase the quality. Back up here, obviously. Let's set it to 5. And let's just go ahead and render that frame. Nice and quick. Now, if we just keep that frame, minimize that for a moment, and now run this through our particle cache. I think all this should be fine. Let's just go with create, and I've placed the existing one that I did just a moment ago, just to make sure that it was going to work correctly. Okay, so they're fully cached now, so we can scrub around and they work perfectly. So we'll go back to the same frame, 72, and let's just re-render again. Okay, so you can see there's quite a considerable difference between the uncached version and the cached version. And the reason why you need to cache these particles is because Arnold needs the cache data to understand where the particles were the frame before and the frame after, etc. So it can actually calculate the motion blur correctly. So anytime you're doing particle work that you're rendering with Arnold, make sure you always cache those particles. Okay? So finally, let's have a look at particle instancing. And to look at instancing, we're going to need to look at stand-ins. So let's make a new scene and have a look at how that works. Okay, so the last thing we're going to do is look at particle instancing. So we're going to come in and we're going to load up our object that we're going to instance. And I have got the traditional Stanford bunny. There he is. Okay, so let's quickly give him a texture. So I'm going to come to my hyper shader. And in here I've got some pre-built Arnold shaders that I'm going to delve into just for speed. So let's have a quick look. What have we got that we could use? Well, let's go with something like this nice gold. So I'll bring this in. I'm going to assign that directly onto our bunny. Okay, so if we just do a quick check, let's see what that's going to look like. I'm going to make an area light. Just going to look through that just in order to position that up. Something like that. Back to our perspective view. Let's do a quick Arnold render. So Arnold and render. It's pretty dark, but we're just going to increase our light just so we can see exactly what we're getting. Let's go with, say, a exposure of, say, 5. Okay, that looks fine. We just want something like that. It doesn't look very interesting at the moment just because we have nothing in our scene that's really reflecting anything. Okay, so we're going to take our rabbit and we're going to save this as a instance. So stand-in export. So this is going to be a stand-in that's going to be used as part of our instancing setup. So we'll call it bunny, and it's going to be saved as an Arnold ASS file, AS file. We're going to be talking more about that in class 10. Okay, so I'm just going to save my whole scene just so we've got it saved. Save it as bunny. Okay, what I'm now going to do is just load a scene that I've prepared for this. And this is just called ground. Okay, so this is the ground where we're going to put the bunny. So what we're going to do is we're going to come up to end particles again, create end particles points, but this time I'm going to use the end particle tool. I'm just going to choose where I want to put the rabbits. So I'm going to put one here, one maybe here, 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 and just click around a number of places just to place our bunny. Let's put one down there as well, and maybe one there. Okay, press enter, and we've now got our particles and our nucleus. The first thing I'm going to do in nucleus is I'm going to say there's no gravity. I don't want these basically going anywhere. I want them just to remain as they are. So if I just make some frames just so we can make absolutely sure they're not moving, hit play. Looks like they're all sat there solid, which is perfect. So we'll just rewind. We're going to have the particles remain selected, and we're going to come up to end particles instance. And that's going to now make our instance setup here. I now want to bring in the bunnies that we're going to use as our instance object. So I'm going to, this time, stand-ins create, come to my path, and I'm going to choose bunnies. In it comes, and here under mode, I can actually say what do I want it to look like. So I'm going to say a point cloud. We can see there is that particular bunny in the center of world space where we created him. Now I'm going to take that instance or that stand-in, control click onto my instance, and then here I'm going to say add the selection, and that was the first thing that I selected. Now if I have multiple stand-ins that I want to use, I select all those first and the instance last. But when I say create, or rather add, you'll see all those rabbits now appear where that particle is. Okay, so you can see they're all there. Now in order to get the rabbits on the floor, we're just going to move that up very slightly. So if we just navigate around to somewhere where we can see the bunnies, and then we're under here, transform, we're just going to raise them up. I'm not quite sure how high. That looks pretty good, somewhere there. The instance itself, I'm just going to hide. So that middle instance that we've brought in, the stand-in, rather, not the instance, I'm just going to hide that. And if I just temporarily hide the ground, just so we can see what we're going to get, and I render, you should be able to see now all of these rabbits in their locations. There they all are coming in. So I'm going to unhide my ground, and also my grass that I've made that I thought would be fun. Now it looks like my poor rabbits are completely swamped by my grass, so I'm going to raise those up even more. In fact, I could just make them a bit bigger. So I'm going to come into my Arnold stand-in, and I might just scale this up just to make them a little bit bigger. Say 2. Okay, so now we can see them. They're almost certainly still hidden in the grass, so I'm just going to hide the grass. Paint Effects grass really is quite heavy when you start using it. Let's grab our instance again. And again, just increase that height. There we go, a lot easier in the channel box. So there are all our rabbits on our hill, which now isn't quite big enough, but it should be okay. We'll re-show our grass. Let's find a nice frame, somewhere like that. And let's do our final render. Let's just check our render settings. That all looks okay. We've got no subsurface scattering and no refraction, so they can go off. So let's just make sure I save my scene. I'm going to save it as ground with rabbits or bunnies to keep it correct. And let's just now go ahead and render. So while that's going through, really this is as far as we're going to get with this class. I was hoping to do volume fluids as well, but I think I'm going to move that to our final class, class 10 miscellaneous, in a couple of weeks' time. Okay, so until then, any questions that you have in anything we've covered related directly into Arnold particles or even just particles as a whole, please feel free to put them in the forums, and I will look forward to seeing you next week and looking at your questions as you post them. And until then, as always, this has been Matt Leonard for FX PhD.